Welcome back. This is Dr. Hadley. This is my series on Microsoft 365 Excel. This unit we're looking at functions and formulas, generic kind of math ones. Today is going to be focused on all the functions associated with rounding. So rounding down, rounding up, that kind of sort of thing. Let's start off with just round. Okay, so that's the main one. That's the one I used a lot, and you can see there's other options like round down, round up, mround, and we'll go over those. But I put the number I want to round. Okay, maybe I want to round 12.519. Okay, but this is money, so I want to round it to the cent, so to speak. So comma. So num digits is how many digits past the decimal point it's going to round. So if I do 2, I should get 12.52. And it doesn't work just for past decimal point. I can do it beforehand too. So maybe I have a number like round 1,105.78, but I'm reporting this number to my boss. This is money. I don't think he really cares, or she, about the cents. So I'm just going to round it to the nearest 100. So comma. So 0 would be where the decimal place is. So the ones digit is -1, the tens place is -2, and the hundreds place is -3. So we're going to have -3 here. I miscounted. The hundreds place would be 2 places before the decimal point. Much better. Pretty straightforward. But let's look at some of the other ones. Okay, because that's always going to round, according to normal rounding rules. If I go back to this one and I make this a 5, it is going to, round it up to 1200. Even if this was like truly 1150, still going to be 1200. Okay. But there is ways to have a little bit more control over it. Specifically, round down. So equals round down. This is going to round it down, but towards 0. So if it's a negative number, it's not going to make it lower. It's going to just make it closer to 0. So, let's use the example they show, 3.1459, comma, but we'll just do 2. Okay, I should get 3.14. Okay, and if I do the same thing for the negative, down, -3.1457, okay, I should still get -3.14, okay, even though -3.15 is technically lower. Okay, roundup works the exact same way, it just goes in the opposite direction. -3.1456, that's going to make it a higher number, so that's going to make it negative. Well, not a higher number, further away from 0. So that should be -3.15, which it is. Okay. The next one is Trunc. So equals Trunc. It's very similar, okay, but it always is going to round it to an integer based on the place you have it. But it really isn't that. It says an integer, but I can even have it, places past the decimal point. I think what makes Trunc easier is that it assumes the number of digits is 0. You don't have to put in the number, but I can if I want. So, I can have 3.1456, comma 2, comma 2. It just drops the number. It doesn't round it. It just says, okay, go to 2 places past the decimal point and drop everything after that. So this could be 3.1499, and it still would round it, quote unquote, to 3.14. The next one we're going to do is called mround. So equals mround. Returns a rounded number rounded to the desired multiple. So what that means is, let's say I want it to the nearest 5. I have 1,224, okay, and I want that rounded to the nearest 5, so it'll round it up to 120. 1225. Okay, but it can be a weird number like equals mround of 33.2, and I want it rounded to the nearest 0.4 or 0.7, which I have no idea what it should be, but you can see it rounded it down towards 32.9. 32.9 is a integer multiplier of 0.7. Similar to mround are ceiling, floor, Ceiling.Math, and Floor.Math. Okay. So equals floor, rounds a number down. So this is, just like mround, you can have that multiple. That would be like equivalent to round. The round down version where I can have a weird multiple like 0.7 is floor. Okay, but you can see there's floor and then there's Floor.Math. So if I do floor, and the difference between those two is how it rounds in terms of negatives. Okay, so if I have Floor.Math, okay, and I have negative 33.1 comma 0.7, just like before, okay, and I leave it be, it's going to make it lower. Okay. Floor.Math negative 33.1 comma 0.7, but if I say 1, that's going to say a different thing. Okay, that is going to round it down based on its absolute value. So the difference between floor and Floor.Math is that forced directionalities. Floor will always make it a lower number. So equals floor negative 33.1 comma 0.7. You can see I don't have a third argument. I only have the 2. And it's going to make it the lower value. Ceiling is exactly the same way. Okay, it's always going to have the higher value. So equals ceiling negative 33.1 comma 0.7, and it's going to make it that negative 32.9. The last 3 are more specialized functions. You could use the functions we've seen up to this point to do the same thing as the last 3 functions, but these are just, it's more, I think, for error trapping so that there's no way you can make a mistake. It's always going to round it in this specific way, and that's even, odd, and integer. So equals even. This is always going to round it to the nearest even away, well, actually not the nearest even, the next even away from 0. So if I do 2.1, it's not going to round it to 2. It's going to round it to 4, because that's the next negative number. The next even number. Same thing if I did negative 2.1, again, away from 0 as much as possible, so that's going to be negative 4. And odd is the same thing. It's just for odd numbers. So equals odd of 2.1, and I'm going to get 3. Now integer is kind of the opposite. It's always going to round down. It's basically going to drop anything past decimal point. So equals int 1.9998. Okay. I'm going to get 1. It's going to drop even though this is pretty much 2, it's going to drop everything past that decimal point. Now, why is that a good thing? Well, if you're doing some sort of math model and that represents something that has to be a whole number, like people, you can't really have 0.998 people, but maybe 2 is literally too much. You have to only have 1. This is that situation where you want to drop everything but the integer. But again, I could use Trunc or any other similar function and get the same, I could always get the same result by doing so. And that's all we have for today. I hope you learned something. I hope you enjoyed this video. Keep watching, subscribe, comment, and I will see you on the next one. Have a good day.